And welcome back to Umbraco Community Day. Purnima, oh yeah, that didn't work, did it? We were going to make a joke about async there, but Purnima had her microphone turned off.
Yeah.
Oh well. Never mind.
The biggest
Yeah,
mistake
indeed.
in
You
these
can't
days.
do can't do multiple things at once, Purnima. You can't pay attention to when the stream's going live and turn your microphone on and make sure we're going to make a joke. It's all too hard.
It is
I'm with you,
hard.
Purnima.
I've just had a sandwich as well, so
Yeah.
I'm sleepy.
Multitasking is difficult. Anyway, we're going to talk about async programming, and who better to talk about it than Jason? Jason's my colleague, and I think we've got him on the line. Jason? Hello.
Oh, I hope so.
Hello.
Can you hear me?
Ahoy, we can. And lovely t-shirt.
Oh.
I'm liking this today.
Ahoy. Thank you.
Ahoy.
I've got surfing Santas. I was in the Christmas spirit.
Surfing Santas. Oh my goodness, yeah.
Yeah.
Incredible.
It's Hawaiian, but also festive.
Yeah, amazing. Amazing. You've given this talk before, Jason?
Yes.
I missed it though, so I'm really looking forward to seeing this.
You might miss it now. I mean, we'll see what happens. My internet is hanging on by a thread, pun intended. So we'll see how it goes.
Fingers crossed. We were just saying in the studio here, maybe all of the traffic is going to finally push it over the edge. Let's see.
I mean, I hope it's not that much traffic, but we'll see. We'll see. It'd be great if the community was that huge, wouldn't it? So
it would, wouldn't it?
Let's see.
Well, Jason, whenever you're ready, off you go.
Super, thank you. If I could have my, everyone's going to need a QR code, so super, it's up. So I'll leave this up for a few seconds. This will take you to a page that's it's just got a button on it. Don't push the button yet. I know it's very tempting. I know I should have put something in to disable the button and stop you doing it. I didn't, so I can't stop you, but please wait until I tell you to. It'll be a bit later in the talk, but it's helpful if you load this up now, and then we can do it. I'll give you a few more seconds, and then I'll move on. So, oh, if my PowerPoint is working, there we go. So ahoy, I'm Jason, a full stack developer. As Callum mentioned, I work with him at Bump Digital, and I'm an Umbraco MVP. I'm not going to say much more about me because I've not got much time to get through all this. I've tested it twice. It was too long, so we'll see what happens. But why am I talking about async? The long and the short of it is I was belly aching on the Umbraco Discord, the community Discord, a few weeks back, and Lottie sort of said, "Hey, well, you're a bit grumpy about these things. Would you care to do a talk on why?" And so I did, and I did it at the London meetup, and I think it went reasonably well, which is why I'm doing it again today. My two gripes were Umbraco doesn't do enough async, and there's still some confusion and suspicion in the community when it comes to async, that it's frustrating, a bit weird, a bit obscure, obtuse, or new, some newfangled thing. I've heard it talked about in the context of. It's not new. It's been a first-class citizen in C# for over a decade, and I've been using it all that time. In fact, I learned C# before I started working in Umbraco, and I learned it when async was new and it was normal for me. Then I came to Umbraco, I was like, where's all the async gone? So there you go. It's a core part of modern web development. It's essential to our app's performance and how modern web apps work, whether that's in the browser or whether it's on servers, whatever. We need asynchronous programming to make things performant, and async await in C# is actually a really nice implementation. For those of us that have been working in JavaScript for a while, we've had asynchronous programming in the form of callbacks, and then we had promises, and now we've finally got async await exactly the same way, or exactly the same usage in JavaScript as it has been in C# all this time. And it's nice that you've had it all this time. It's really nice. It's really straightforward. I can't afford to spend too much time going really like a real deep dive into this, and frankly, no one wants me to do that. So I'm going to skip over some bits. There'll be some oversimplification. The key thing I want you to try and take away is why it's important and what it's doing, why async await improves the performance of your app. To do that, you're going to need to understand a little bit about threads. I'm sorry, threads, but bear with me. We'll just get through this quickly. Threads allow a single process to do more than one thing at a time. So they're a feature of your CPU that lets processes, programs do multiple things at once. That is super important for us as web developers. If you think about other applications, I don't know, like Photoshop or Microsoft Word, whatever, when you're using it, you are one user doing one thing at a time, and you don't really have to care about multiple concurrent operations, multiple things happening at once. when we're building websites, we're building apps that are serving tens, hundreds, maybe thousands of people. We need them all to be able to run and execute code at exactly the same time. And so we have this, well, it's an issue. It's something that we have to build into our apps so that they are performant, so they can handle all that traffic. And it's kind of a somewhat unique problem for web developers. In .NET, threads live in a thread pool, or in fact, I should say first, in .NET, all of our code that executes always executes in the context of a thread. So if you've got running code, it is running in a thread. I'll show you that in a minute. That is how .NET schedules our code to actually execute on a machine's processor. So the thread is always a thing. And in .NET, in ASP.NET specifically, they live in a thread pool. So if you think of lots of users coming to your site all at once, that the thread pool is there full of pre-warmed threads ready to give to users as they come in, or to use for requests as they come in, I should say. There's a practical limit to those, and they're expensive. So you can only really have so many threads on a machine before it doesn't work. They have a memory footprint, and they're sort of limited based on a combination of how many CPU cores or how many CPU native threads you've got. And how much memory you've got. So they're kind of bound to your hardware in terms of how many you can have at any given time. So async await is about reusing threads. I'll show you that specifically in a minute. But first, if you haven't already, please do head to this random page because I need you to get a thread ID. And we're going to test it. We're going to see if this works. This is going to go one way or the other. So this is where we need a bit of audience participation. I'm just going to click reset on this. There's lag. So the easiest way to do this, I think, is for me to like count down from like 5, and you will click this button at about the same time. And we'll see if it works. If it doesn't, I've got a backup plan that may work. So hopefully you've got some time. Hopefully you're at this page. And I'll count down from 5 now. So 5, 4, 3, 2, 1. Smash that button, and let's see what happens. I'll smash it too in about 10 seconds. There we go. It says hold tight, it'll take about 10 seconds. That's not the time it takes to get a thread ID. I've actually just added 10 seconds of latency just so that I can hopefully get you all to sync up at once. And hey, and I've got thread number 42. I'm going to pop that in the chat over there. I'd really love to know what thread IDs you all got. Stick it in the chat. I can also go over here and I can see that, there we go. Number of unique threads in use is 16. Hey, look at that. 17, it's going up. 19. So I've got in fact, I should probably show you the code of what's going here. I've just got a little dashboard to say what's going on here. And if I drop into C# or drop into, whoa, that's a lot of windows. There were not that many when I tested it earlier. Right. So I've got my thread ID controller here. And all I'm doing is I'm just thread.sleeping. So you're making a call to this thread ID endpoint. I'm sleeping the thread, getting the thread ID, and I'm logging it so I can see how many are in use. That is all that's happening. And broadly speaking, if 2 of you are hitting this at the same time, you're getting different threads because I've made a thread sleep. So ASP.NET needs to pull one out of the thread pool and provide it for you to execute that request. We'll come back to that later and see why that's what we can do about that actually. Oh, while I remember, how many threads are we at? Oh, it's this one. 19. So we're still at 19. Okay, brilliant. That's a good healthy number to be at for this anyway. It means you're not going to DDoS my app anytime soon, basically, is what it means. So let's look a bit at async then in action. So we're going to dip back into my app, and I'm just going to show you. In fact, I'm going to show you one of my. Here we go. So I have let's just refresh this to make sure it's all working. So I've got an endpoint, 2 endpoints, in fact, one called async cheese and one called cheese. They both do broadly the same thing. I'm just going to try it out and hit this endpoint. Let's close PowerPoint just so I can see that I'm hitting a debugger. So here's my my cheese endpoint. It goes into a service that makes some cheese, basically. If I hit continue and we wait a bit, cheese took about 5 seconds. About 5 seconds to make. Oh, that's interesting. Yeah, it took about 5 seconds to make. It's good because I told it to sleep for 5 seconds in my my make cheese method. So that's helpful. So continue, and I've got another method up here, async cheese. Exactly the same sort of thing going on, except we'll just carry on here. Here we go. I've got more breakpoints, which is annoying. I should turn those off. Let me do that again. Yeah, 1 millisecond lapse isn't helpful. Sorry, that's the first thing I did wrong. Hey, right, let's try that again. So I'm gonna hit that endpoint again. Here we go. We're making cheese. It's taken about 5 seconds. Who knew it took about 5 seconds to make cheese? There we go, 5,003 milliseconds in this instance. The timing difference between the two, don't really read too much into it because the timing isn't perfect. We're not actually accurate in terms of the time that's happening here. It's just it's rough when we say thread.sleep. So as far as we're concerned, then both these controllers are doing exactly the same thing. One is sync, one is async. If we go into our actual make cheese task, we'll see the difference between the two is this one's using task.delay and it's returning an async task of cheese. When you use async and await, you have to return a task. It's best to return a task. The reason, the reason for that is we basically need a teeny tiny state container, which is what task is. It's a teeny tiny state container that wraps this here task, this code, whatever it is that's executing, just so that we can keep track of where it's got to, and we pass that back up the call stack. So let's just I'm going to refactor this async cheese controller just to do something a little different, just so we can see what oh, my watch has gone. Okay, I'll put one in later. Just so we can see what make cheese async is actually doing. So instead of awaiting cheese async here, I'm going to change it to be a cheese task. I am going to await my cheese task there. And in the meantime, I'm going to, hey, look at that. Thank you, Copilot. That's a nice, thank you. So let's go back to this make cheese async method. Let's hit it again. Right, so we've hit our method. We're awaiting. Now, what this await task does, and pay special attention, I know it's teeny tiny, we're on thread ID number 7 down here. I'm using thread number 7 of all the threads I've got at the moment. I've got available at the moment. Await, what it's going to do, it's just going to say, hey, this is going to take some time. So I'm kind of emulating a network request here or some other service, anything that takes is basically would otherwise be blocking IO. It's going to say, hey, rather than kind of block the thread here, let's return the thread back to whatever called this, and that's all that async await does. It just says, hey, whatever thread we're using to do this, we don't need it anymore. It's done. We're going to wait for this, so we're going to return it back up the stack. We're going to return it here, and now I can do console.writeLine, do other stuff, and this has happened. Make cheese async. It's not doing anything in the background. There's no background threads. There's nothing like that going on. It's just literally, if this is like a network request, or if we're asking the CPU to wait a certain amount, to await, or for a task to take a certain amount of time, there's nothing actually going on. We're waiting for a response from that task before we do anything else. So we're free to carry on. We're still on thread number 7. You can see down here. And then we're going to await the actual task to get the result. And it's going to return some Comté, a nice, delicious, one of my favorite cheeses, actually. There you go. Now, this is quite probably an unusual, like, perhaps unlikely to do this. Like, the amount of time that you save by doing that, or the amount of efficiency you get by doing it, is kind of irrelevant, right? Maybe you want to do multiple things before returning a response to a user. Maybe you need to make multiple cheeses, in which case you can totally do that. And not take 10 seconds to make 2 cheeses. You could make 5 by having 2 tasks. The point is, we're freeing up the thread, and the thread can do whatever it needs to do. It can do either code that we've just added in and that we want that thread to then do, or, and bearing in mind that when we use async await, we have to change the whole, like, every method it touches. I mean, it's a bugbear I know of people that, oh, you know, as soon as I use async await, all of the methods have to be async task of whatever it was before. Well, the reason for that is because that's the only way you're going to get that thread back up into the calling method, right? Now, I don't know how this works in ASP.NET. I don't know what's responsible for calling this, but just by doing this, I've made that thread then available for, say, there's some sort of request scheduler in .NET. So I haven't really looked into it. I don't really care. But that thread is now available to reuse. Maybe that thread can be used for someone else to come along and make some cheese. Maybe another user on the system, whatever. The key point is we've stopped sort of hogging that thread. We've stopped using it, and it's gone back to gone back to the calling method to be reused. Hopefully that makes sense. That's kind of the only really important bit to take away, is that is all async await is doing. Let me pull this up, because this is where things start to get a bit more interesting. So when we think about it, like this is, you might think, oh, you know, how much time am I actually saving? Well, let's think about what the bottleneck is in our code. It's like the CPU. Let's say a processor runs at 2 gigahertz, right? That means it does 2 billion calculations per second. This is an oversimplification, but just bear with me. So if we're asking a CPU to wait for 1 millisecond, that's 2 million cycles. That CPU could literally have done 2 million other things, right? It could have done 2 million other calculations. So where we think, a millisecond is not much, if we're asking our CPU to wait for that, well, think of what else it could be doing. If you're not using async await, then potentially, in fact you are, you're over provisioning. You need a more powerful CPU to do basic stuff. I'll talk about that a bit more in a second. Oh yeah, it's a lot to process. Yes, and 0.68 seconds for an Android, that's nearly an eternity. So it's, when we're thinking about performance specifically, like it's important to think, you know, at scale, at CPU scale, we're talking nanoseconds, microseconds. We think milliseconds, you know, what difference does it make? Well, if it's happening for hundreds of thousands of users all the time, it all adds up. And it is a sustainability issue, actually. So what are we waiting for? Well, all I/O adds latency, or all blocking I/O adds latency, I should say. So think about network calls, TCP calls, any HTTP API you're calling, calls to blob storage, to Redis. Redis isn't a HTTP API, is it? Anyway, it is an API. It's a network call. The database, disk, all of those things are slower than your CPU. So while you're waiting to get data back from those things, if you're asking a thread to wait, you are wasting time. Your CPU is doing, that thread is doing nothing when it could be doing something else. It could be being useful at that point in time. Just to go into the HTTP APIs more specifically, to sort of break down the order of a request. So you think about what we do. We make a request to another machine over the network. We wait for the response. We wait for the response, we wait for the response, and then we do something with the response. And if you think about, I mean, this friendly diagram over here, when something is over the network, I mean, even in like a data center in Azure, right? If I'm talking from my web app to my database, yes, the machine is physically in the same building, but they're not connected with a wire. There's stuff in between. There's network switches and cables, and it's physically further away. The speed of light is what it is. If something's further away, it takes longer to talk to it. So whenever anything's over the network, we're always adding latency. There's nothing we can do about that. It's just how it works. But what we can do is then use async await to do stuff while we're waiting. And in modern web apps, where we've got more and more microservices, more and more stuff being farmed out to TCP calls, HTTP APIs, whatever, there's more stuff that we should be awaiting. And why did I list these in particular? Because in an Umbraco site, these are the kind of things we're used to doing, right? We're used to using blob storage, especially if we've got a well-architected, scalable Umbraco site, right? The docs say use blob storage, don't use session state, or if you have to use session state, pop it in Redis. You can't not use the database, you can't not use the disk in Umbraco, you've got to do it. Now, if you're scaling an app, if you've got to move storage into blob storage, you've got to move your media into blob storage, say, well, you're taking away what was a call to perhaps quite a fast local SSD, and you're putting it over a HTTP API. It's a network call away. Same with Redis. If you're taking a session state out of memory, it was in memory. Memory is really fast. If you're putting it in Redis, well, that's now a network call away. Database, I mean, disk, well, we're kind of stuck in Umbraco. Umbraco 9 is much better with async than Umbraco 8 was, but our kind of core services, a lot of them are still synchronous. A lot of them are blocking, and a lot of them, well, you can't escape that fact. Now, in my experience of dealing with performance in large Umbraco applications, the problem you come up against, especially if you've got a well-built application, the problem you're going to come up against is thread starvation. It won't be that there's not enough CPU or enough memory. It will be there aren't enough threads to handle all the requests that it's being asked to do. And so the only way to get out of that is to scale horizontally, or to add more cores, which is okay, but you don't need all that CPU. You're not asking the CPU to do anything extra. You're just freeing up more, providing more threads, and you don't need to be. If you're using async await, those threads are available because they're being returned back to be reused, and it's a much more efficient way of doing it. So let's refactor. This is going to be disastrous, but let's refactor our original thread ID controller. Hopefully you've still got this link somewhere. I'll put it if I got it. Actually, let me put it back on the screen for a few seconds. It's this one. So just head back there, load up this page again. I'll get you to count down in a minute, not just yet because we need to refactor it, but keep this around in the background. And we'll refactor our thread ID. So instead of sleeping, we're going to use task.delay, and we'll still have delay for 10 seconds. That seemed to work pretty well last time. Plus, if I change it now, it's not a fair test. Let's let .NET be helpful and make the method async for us. See, .NET Visual Studio, like it's not hard to refactor. Like it's pretty nice. There we go. Now, what's going to happen here? This is the quirk of it's to do with routing. Oh, and it's changed it to async. That's why it didn't work last time. Anyway, I can't just hit the nice hot reload icon on this to get everything working. I do need to stop and start my app again. So let's load up this. Oh, you don't want to see my swagger, right? So and let's load up the dashboard that I've got. So I'm going to reset this, or in fact, I've just rebooted the app, so it's only in memory. That's fine. So let's try it again, right? Let's do a countdown. On a countdown from 5. Everyone hit this button when I get to 0. So 5, 4, 3, 2, 1. Smash that button, and I'll smash it in about 5 seconds or so. For the lag. There we go. Okay. So now on my dashboard. I mean, it could be that many of you have gone away, right? And you're not watching this talk anymore. It's terrible. You've given up. And I should have put some analytics in to check this. But hopefully what we'll see is a far fewer threads in use. Super. Yeah, do share your thread ID. Here we go. Yes, excellent. So yes, it worked. Nice. 18. Everyone's using thread 18, right? That's excellent. So .NET, if it can reuse the last thread it used, it will. I think it tends towards that. And so this is why we're seeing many more 18s and 19s than we were before. As soon as it's done, it goes back to be reused. This is exactly it. So I'm now using 3 threads to do what took 19 threads before. That's huge, right? That in terms of if you've got an app that has got its issue, its bottleneck is thread starvation. We've just, I know what, there's a third as many CPUs, a third as powerful instance as you need to power this app. That is what async does. That's the performance difference it makes. I say a third. We could change it. I mean, maybe we could say this instance could handle 3 times as much traffic, right? It's capable of doing that. That's the difference it makes. That worked. That's nice. How much time have I got? Oh, good. Okay. I was worried that would take ages. So we have done this. So that's the key bit. If you only take away anything, it's just that. Just use async await. Let the threads fly free to be reused for other things. We've got a bit more time though, so I'm going to talk very briefly about the exception to the rule when it's not okay to use async. I have in my app, and I'm going to refactor this for you live as well, because what else could go wrong? Right, I've got a really simple. I'm loading a text file here, right? I'm just doing that here. There's nothing special going on. And I'm just measuring how long it takes. I'm measuring it in ticks. We're talking about microseconds here rather than milliseconds. So we're kind of a whole level of super nerdy performance lower than your usual millisecond check. And I'm going to hit my API, or if I can find my API on here. Here we go. So let's find my Swagger. Let's hit this. So I'm gonna do this a couple of times because there's it's not a fair test otherwise. So it took 61,000 ticks that time. Let's try it again. It took 15,000 ticks. Okay, so that's the sort of that's what we're talking about. So this isn't how you do performance testing, by the way. Like, this isn't a fair test. This is just anecdotal, showing you how quickly this is executing on my machine. Okay, this is just to show you the difference that this is going to make. Don't think I'm doing performance testing here. That's not what this is. 20,000 again. So about the 20,000 mark, which makes sense because I've tested this before. So I'm going to refactor this the other way. I'm going to stop this being async, and I'm going to do this synchronously. And again, I'll get async. That was naughty, wasn't it? Again, I'm going to need to stop and start my app. So remember, we were about what 20,000 elapsed ticks. We're going to hit this again, and we're going to try and see how long it takes to do. Oh, I've hit the breakpoint, haven't I? There we go. 5,000. Okay. 3,863. That's a lot less than 20,000. Hopefully that's obvious. So there are places where async doesn't make sense, because in this precise case, yes, file.readAllText is blocking I/O, but my laptop here is a really, really fast NVMe SSD in it. It's lightning quick. It's faster than .NET can put all the async await magic together to actually run the async version of this. So it's more efficient in this precise instance to say, well, let's load directly from the disk without awaiting to bring it up. Without awaiting, we'll just load it and we'll block, and it is faster. So it's something to bear in mind. Now, in your usual web app, actually the only time this is going to come up is if you are hosting a web app that happens to have a super fast SSD. In my experience, if you're hosting on Azure, the SSD isn't that fast, so you might still want to warrant an async await. Your SSD in Azure might be different to mine, though. And this is one of those things where, actually, as much as we like to think about containers and then we can just ship our app and send it out and not really care about the hardware, sometimes it does matter. And this is one of those instances. This could make a huge performance difference if you've got an app that's doing a lot of stuff with a disk. Okay, so this is one of those times where actually you do need to know what hardware your software is going to end up running on in production, so that you know which is the best option here. Should I be using async await, or should I be just blocking this and just doing it using the normal APIs? And the last one. I've changed the title of my talk at this point, because actually it's not really about async. Like, async doesn't do anything. All the magic is in await. Await is what tells our code that we can let the threads go and do stuff. Async is just there to say, hey, this method can be awaited. So await most of the blocking I/O instead of async all the things. And then stuff in Razor. If you have your front ends running in Razor, this is a pain. It's not a pain. It doesn't really matter. Like, it's just a tiny refactor. Don't use partial or render partial, because they are blocking. They deadlock Razor, apparently. Here's me thinking, surely Razor's just slinging stuff together in memory. Well, yeah, but it can deadlock. So use partial async and render partial async in all of your views, because you don't want to deadlock Razor. And again, if that's something that's happening in your app, just doing that tiny thing will get you a performance boost straight away. And that was everything. I rattled through it at lightning speed. And as I said, I made a shed load of oversimplifications. So if you want to pull me up on those, by all means, drop it in the chat. Get in touch with me on any of these channels. Thanks for making it to the end. And hopefully I convinced you that we need to be using async await more in our code. We need to be perhaps asking Umbraco to get some more of those core services over to be awaitable, so that we can actually get a bit more performance out of Umbraco. iFile system is my biggest gripe. We do a lot of stuff with disk, and yeah, that would be nice to be async. So yeah, I'm done.
Thank you, Jason. That was a great talk. And it's always good to learn something more generic .NET beyond Umbraco, because it just helps you get that extra edge as a developer. And there were some exceptional tips and tricks that I'm pretty sure the community would be really inspired to go and have a look at. So are there any questions for Jason in the chat? None that I can see, but there is feedback pouring in the form of great talk. Just as I
Oh,
said,
lovely. Thank you.
it was just fabulous. And of course, we all got a chance to DDoS your machine, which we didn't.
Well, it
really.
didn't happen, did it? So, yeah. When I do it at London, I did say, please don't anyone kind of hit any of these URLs and breakpoints until I tell you. And there was one person who will remain unnamed that took great pleasure in calling random methods on my machine while I was trying to give the talk. But thank you, community, for being so lovely today.
Thank you so much. And thank you once again, Jason. So that was Jason. And while we have the next speaker, Roy, setting up and prepping to do the talk for us, let us take a break very quickly and come back.